What is up, everyone? I am super grateful to be here at Upstream 2024. My name's James. I'm the founder of Latio Tech, which is a bunch of resources to help you learn product security as well as find tools in the arena. I am also a security engineer at PagerDuty. I have a background in DevOps, DevSecOps, all of that stuff. But today, I am very excited to hop right in here and talk about open source and CVEs. I know that at this conference, there are both people here who are maintainers of open source projects, and there are people here who work for companies that use open source products. And really, CVEs are at the root of a lot of frustration between these two groups of people. And I've been someone who's been on both sides, right? I maintain some small open source projects. I've been involved in the community a little bit. I'm not like the world's biggest open source maintainer or anything, but I've dabbled in a little bit of it, like many people. And conversely, I have worked with compliance people trying to figure out what do we do about these CVEs and our compliance processes. And what I'm hoping to get out of this conversation today is really helping people look at both sides of this problem. I can move my head out of the way here too. I'll move myself back after. But essentially, we're going to start by talking about why the process is the way it is, what's sort of the painfulness that happens. And then we'll talk about what compliance teams can do to help maintainers. Then we'll talk about what maintainers can do to help compliance people. Then we'll talk about some different options for moving forward. And really, the goal here is to find our way out of the CVE dungeon in which we have unfortunately locked ourselves. So first, let's talk about the current process. So this is sort of the frustrating game that we all play that can be super annoying to deal with if you've received some of these. I just went on an open source repo here and found sort of the first example, and there are so many of these things. I cringe so much as a security professional every time I see one of these. So Orca Security Scan finds vulnerability CVE 2023 in this repo. Right. So the scanner that the company has bought, so whether they're using Orca, Sysdig, Wiz, Aqua, no matter what, first of all, it's probably Trivy under the hood. But once that scanner finds a CVE, there's something that compliance teams don't really know what to do with it, right? Because they've scanned this image that they're ingesting from an open source project that they're treating as though it's a vendor that they're paying for. Then they are reporting that CVE as though it was a confirmed vulnerability to the vendor and asking for a timeline to fix it. Oftentimes, you can see this was open March 6th, the CVEs sort of just get ignored or fade away into oblivion because there's no clear policy of what do we do, right? This is a frustrating process for maintainers because they are just given random CVEs that they're supposed to waste their time going to investigate. Frankly, because the compliance team was too lazy to actually do the investigation themselves of if there's a vulnerability there. So to be fair to compliance teams, I wanted to show why it's not just laziness that causes these issues, but container vulnerability scanning is just extremely complicated, and it is a huge battleground for false positives. And I have a whole video on this problem called Container Vulnerability Scanning Sucks on the YouTube channel if you want to dig more into it. But just to give an example, in case you're unfamiliar with what security teams are seeing, first of all, a lot of tools don't even separate this base image from the rest of the things that are getting added from it. But this is showing fixable things on the base image. And obviously, this is stuff that you don't have direct control over. This would be just running a regular update against the base image is what would show this. But this already shows a level of understanding of containers that frankly some teams don't have. But then if you go into these, you would think are vulnerabilities that you can actually fix. But you'll notice here the first three things that show up are different standard libs with critical vulnerabilities. So you're thinking, oh, we got to freak out. We got to, like, I would publish this CVE against the Argo page to say, not all JavaScript characters are considered white spaces. And you start thinking, oh, do we use JavaScript, or wait, this is in Golang and it's not properly sanitized. Like, what? How does this impact anything? It gets very complicated very quickly to try to figure out, am I actually vulnerable to this vulnerability or not? And at the end of the day, if you look up this package in the package list, you'll see that it actually comes from Customize. And so really, Argo CD isn't who you should be reporting the CVE against at all. It's Customize. And within that, there's its own level of complexity around figuring out the vulnerability or not. And so that was just one example, but then if I go to this, um, we see that it's from Helm. If we go to this, we see that this one is from Argo. And so then this is the one that we would be tempted to investigate. But then we are right back in crazy territory where we have to figure out, like, really, this is an issue with Golang and how the HTML template interprets JavaScript. Just as sort of an arbitrary example, you are really asking a lot of maintainers to go through all of these various findings, and it's really difficult to try to just share this to someone without even understanding, like, we add additional filters here like fixable, reachable to try to help. But at the end of the day, it really requires taking some time to understand, how is this application being built? And are these packages being used in ways that can actually be exploited? So reporting these vulnerabilities like this create a lot of shared pressure between security engineers who don't know if they can fix it or not. They don't have enough understanding of the application that they're using, and maintainers who feel a pressure to hop in and try to fix it immediately, even if there's not a true positive there or anything like it. And so here's just some of these reports can get absolutely disrespectful, where everything from, like, please do the needful, Wiz reported this, Trivy reported this, there's a bash vulnerability, and then you see in these threads, maintainers having to spend their time going back and forth with people discussing whether or not they're vulnerable to the CVE. And so that's why I want to spend some time. This is clearly a painful process. So I want to help maintainers understand why compliance people do it. And then I want to help compliance people understand the difficulties that the maintainers face. Let's first understand why compliance does it. I linked here to the continuous monitoring strategy guide that is part of FedRAMP. So I've learned a lot about this recently going through FedRAMP myself. But within the continuous monitoring program, you have only 5 things to do with a vulnerability. You either fix it, you call it a false positive, which is where you know that you're not affected. You risk adjust it to say that we have compensating controls that make it so this is not as vulnerable as it looks like. You call it an operational requirement, which is a way of saying that we know that this is a vulnerability, but we will go back and fix it in a different way, in a different period of time. We're choosing to accept the risk of this over a period of time because of an operational requirement we have where we cannot fix it. And then the final category is a vendor dependency. Now, vendor dependencies are where these CVEs by default have to fall. Even though open source maintainers don't have a contract in place to make them a vendor in a formal sense, nonetheless, that's how they have to be treated, because there's really no other options for what to do with these vulnerabilities when they're discovered. And so when you have a vendor dependency, your guidelines are forcing you're supposed to check in with the vendor upstream every 30 days for either them to confirm that it's a false positive or for them to give you their timeline for remediation. And so that is the process for what compliance has. And what you can see is if they are following from a strict compliance viewpoint here, the number of options they have are very limited for how to report these findings to a vendor. Now, there's one path, which is what I would argue compliance teams should do instead, which is to consider these things as false positives unless they're recognized by the vendor. Because often these CVEs are against transitive dependencies, they're against different parts of an image that are unused. Unless the CVE is directly against the project, I would argue pretty strongly that it should be default considered a false positive unless the CVE is directly against the third-party package that is getting published. So a good example of this is with Argo CD, who I'll use a couple times over the course of this presentation because I think that they've handled this extremely well, is Argo has had CVEs published directly against them, indicating that there's a mature disclosure process, they are being tested for vulnerabilities, but they also, by nature of having container images, transitive dependencies, have vulnerabilities as part of their transitive dependencies. And I would argue that it's irresponsible to report those to them, especially when they are directly taking disclosures themselves. So all that to say, this is why compliance does what they do. So my best argument here is if you're here today and you are part of a highly regulated environment, is to try to talk to your auditors about the idea that you treat these as false positives by default unless they are reported directly against the vendor, in which case you will consider it a vendor dependency with open source software. The other piece is if you're not under a FedRAMP environment, you do not have this sort of strict stringency to which you're held accountable for your CVEs. And so it's highly unlikely that you need to even go down this rabbit trail. And instead, you should try to use concepts like reachability, like VEX statements, like compensating controls to try to make this same argument, to think of scanner results in the raw as largely false positives unless they are directly against the package itself. So moving on now to how maintainers can help. So the first thing to say is that the dumb policies that we all hate writing, we hate dealing with, they actually go a very long way to providing you ammunition as a vendor to say, hey, this is our policy on CVE disclosure. Here's what we accept, what we don't accept. And I linked here to Argo's security policy because once again, I think that it is extremely good. I'll go ahead and open that up here. So here we have Argo's security policy. And so they talk about the importance of security and that they do take it seriously. But really critically, they have this word about security scanners. And this is the part that I think is really, really helpful. And they explicitly call out, we kindly ask you not to raise issues or contact us regarding any issues that are found by your security scanner. Many of those produce a lot of false positives, and many of these issues don't affect Argo CD. We do have scanners in place for our code, dependencies, and container images that we publish. We are well aware of the issues that may affect Argo CD and are constantly working on the remediation of those that affect Argo CD and our users. And within that, they then quickly say, if you believe that we might have missed an issue that we should take a look at, that can happen, then please discuss it with us. If there's a CVE assigned to the issue, please do open an issue on our GitHub tracker instead of writing to the security contact email, since things reported by scanners are public already, and the discussion that might emerge is of benefit to the general community. However, please validate your scanner results and its impact on Argo CD before opening an issue, at least roughly. So this is super important to call out the desire to at least do some minimal validation before you report a CVE to the vendor. This is super important. First of all, it shows a high level of charity from the Argo team because they're under no obligation, frankly, to look at these scanner results at all. But to ask this, it says, hey, we still are open to the idea that we could have missed something, but you need to at least do some validation. So the work is on your part, not on ours. And so this is a policy that I highly suggest adopting. And then they also include how to report vulnerabilities through a couple of different ways. And I just really think that all of this goes a long way to showing a mature security policy that balances both customer needs to report issues with the realistic issue that scanners right now are in an extremely volatile state as far as container scanning goes, and how they're unpacking and scanning within the compiled code assets of every dependency that's on there. And it's highly unlikely that most of those are going to affect your particular repo. And just to highlight it real quick, this is the issue that had the Orca scan example. And this allowed me to come in and just comment and say, hey, if you look at the security policy, this issue is not going to get addressed unless you provide some evidence that it should be. And just having that policy there makes it so that you don't need to waste your time going through this response and trying to figure out, all right, are we vulnerable for this or not? Because our temptation when we get one of these CVE reports is to try to create some sort of reconstruction of if this is a true positive or not. And having this policy in place means that if the issuer is not presenting some evidence they've already done that, you can just point directly to the policy and say, hey, if you want us to deal with this, go ahead and do some testing of your own so that we can at least have the validation in place. So alongside that, I think automating your image builds is the easiest way to also get a lot of these vulnerabilities taken care of. The minor version of Upstream Ubuntu images, so like 20.04, is regularly patched by Ubuntu. And so if you're just regularly running a GitHub action every night to rebuild your base image and publish it to Docker, that goes a long way to make it so that customers, if they just scan the latest version of your image, which is what a lot of these scanners are doing, they will see that there are no Ubuntu fixable vulnerabilities because you are automatically building that image and publishing it. So then I would really suggest that you ignore everything else. I think a fundamental mentality switch has to happen in the world of container security, where it used to be that every time we received a vulnerability back in the Windows days, we did not try to discover if we were actually vulnerable to it. We just patched the vulnerability because the action of running the update was less time intensive, risky than trying to figure out if you were actually vulnerable to the CVE, except in rare cases where it was an actually super critical CVE that had to be dealt with in the most immediate kind of manner. And I think we need to take a similar approach when it comes to open source software and Ubuntu to just letting the patches happen. If we get a CVE report, we need to trust that we can just run the next version of the image. It'll probably get patched. And unless it's something that's really critical that a user is calling out to us as being exploitable in our context, we should have the freedom to move on with our life from it. So, what are some better ways forward here that we can make more sense of this CVE back and forth that happens? The first, which is something I'm always advocating for, is that we call open source maintainers vendors when we treat them like vendors, and we publish CVEs and expect them to fix them as though they're contractors. And so we should actually pay them and have some kind of contract in place as though they are vendors or contractors to establish the relationship ahead of time. It's extremely unfair how we expect them to patch CVEs without having any formal relationship to us. Another option is to, when you see a vulnerability, actually try to patch it yourself and contribute it upstream to the developer. Every time that I've given a developer a third-party vulnerability ticket, I've given them the option to either do a manual override, which is never a great option when you're dealing with dependencies, or to contribute back upstream to the main repo to fix the vulnerability for everyone. And I think more and more companies should encourage their developers to, if they notice a outdated version with a CVE on it, to try to patch that and open a pull request and go about things that way instead of just opening these pull requests or these issues that have a bunch of CVEs on them. And then a final piece of that is also only reporting real issues that have been validated and tested ahead of time. So something else I really wanted to touch upon here is the recent XZutils attack, because a lot of issues with upstream malware detection can get conflated with this sort of CVE approach. And we can say that they're both fixing security upstream, when in reality, I would argue that they're actually pretty different issues. As far as CVEs are showing the known exploitations of software that are unintentional, whereas malware is getting published to an open source repo in order to do some malicious activity. And what's really interesting about XZutils is that no amount of upstream scanning or scanning for CVEs is really would have detected the issue or fixed it, considering the nature of the exploit of being published via obscure code that only executed once it was compiled, and then having it get adopted by upstream maintainers sort of without people knowing about it. Really, I would argue that this exploit should force us to rethink entirely how we handle our relationships with open source maintainers. And it's because, again, we need to treat people as though they're actual vendors, actual contractors that we are going to and using their software. That gives us some amount of understanding or relationship of what's happening. Who is the new maintainer of this software? What are they doing? What's their background like? Does this change at all if we want to continue to use this product? Every time there's a major breach or a news story with a vendor that we use, typically that raises the question of, do we want to continue to use this platform, right? I remember most famously recently when there were questions about how Zoom was using its AI, a lot of companies began having internal discussions about, oh, does this affect how we want to use Zoom? Do we need to stay with them? Is this a big deal? Zoom had to do some clarification. Companies had to make their own decisions. And similarly, these different upstream processes, packages that ironically have much greater visibility into our business than Zoom does, we just treat them as though it's okay that they're just totally black boxes that we have no insight or relationship with. Instead, it's like the CEO of a company leaves and a new one comes in, is what's happening when maintainers hand over the keys to someone else. And that should be part of this relationship that we have where we're tracking open source vendors that we're using and how we can build healthy relationships with them. And what's interesting is that the scanner mentality has actually diminished a little bit of how we think of this correctly, I would argue, because when we scan open source repos, we're being told by the vendors that this is part of doing security, right? As we're looking for CVEs issues so that we know that our upstream repos are secure, that we're secure against attacks. But this really revealed that it's not really a scanner problem to achieve upstream security. Upstream security is about building meaningful relationships with maintainers whose software you're using to make sure that you can actually trust and reduce risk of supply chain takeover, as well as when CVEs happen, you actually have somewhere to talk to get a fix published. That there's actually some sort of guarantee, first of all, that there is some ongoing security processes that are in place beyond the security policy and what's written, but then that you can also have fixes that will get published in a reasonable amount of time. So all of this really points more and more to if we want to solve the heart of this problem, it's not just additional scanners. Like all I do all day as part of Latio is talk to different vendors who are offering different approaches to how to secure the supply chain. A lot of that visibility is very good and helpful for companies, but it really misses the core of the problem, which is that we take open source contributions for granted, and we need to stop doing that in order to not just like be kind, altruistic people, but because if we think of something that Zoom is doing with their AI as a business risk, how much more of a business risk are essential open source functions of our application, and how we build and maintain those vendor relationships needs to really be leveled up. So thank you for attending this today. I hope it was helpful. I hope that as a result of this, you both feel like as a compliance person or as a security person, you have some tools to help make it so that you don't have to report these vulnerabilities upstream. And if you're a maintainer, I hope you were helped by the different policies and options you can point to try to cultivate a healthier relationship with regard to handling CVEs that are sort of thrown over the fence to you. So if you want to reach me, it is super easy to follow me on LinkedIn or just send a connection. But beyond that, if you go to latio.tech, there's a ton of resources, a Discord community, a YouTube channel, lists of vendors, all sorts of things to try to help us do product security more holistically in a way that actually works, instead of just sending these sort of meaningless reports all over the planet and people just wasting believable amounts of time chasing things that don't actually cause issues or exist.